Quadratic equations are solved using methods that we know, and maybe one or two that are kind of unusual, but if you practice it, it should be fine. Before we move on to actually solving those equations, let's practice factoring first, because it's going to be very important for some of the methods. So if you don't remember, you can go back to a previous video about factoring. There's a few steps. The first thing you should always ask is there a greatest common factor I can take out? Because that's going to make my problem a little bit easier to solve. So in this instance, 4x squared plus 16, I can take out a 4x. That leaves me with x plus 4. And both of these terms are what's called linear terms. Namely, you cannot factor them any further. They're not x squared terms in them. They're the lowest power of x is just 1. Right? Both of these x's have just a power of 1 on there. And that makes them linear. Because they're linear terms, that means we've factored it completely. So that one's actually already factored. Now for this next problem, this one does not have a greatest common factor. There's nothing can be taken out of x squared, negative 14x, or 40. So we move on directly to either a binomial, trinomial, or something greater than those. This is a trinomial. There's 3 terms here, right? We have 1 term, 2 terms, 3 terms. So it's a trinomial. In trinomials, you can use the AC method to try and factor it. The first thing we do is we look at a, b, and c. If you don't know, ax squared plus bx plus c. In this case, a is 1, b is negative 14, and c is 40. We look at a times c. A is 1, c is 40, a times c is 40, positive 40, and b on bottom, negative 14. Now, on the sides goes 2 numbers that multiply to give the top, or positive 40, and add to give the bottom, negative 14. 2 numbers that do that, after a little bit of thinking, you'll get negative 10 and negative 4. Negative 10 times negative 4 is positive 40. Negative 10 plus negative 4 is, in fact, negative 14. Now, we can follow along with the rest of the AC method, but we don't have to because a here is 1. If a is a positive 1, then there's a shortcut. This thing can be factored immediately into x minus 10, because we have a minus 10 here, and x minus 4, because we have a minus 4 there. You just write x and then either plus 10 plus 4 or minus 10 minus 4. Whatever sign is the number is. If it's positive, write a plus. If it's negative, write a minus. And that is completely factored. So I can clean up this a little bit. And there you go. You can see the AC method factors that down to x minus 10 times x minus 4. These are both linear terms, so we know we're good. Okay, x squared minus 144. This is a binomial. There's not a greatest common factor. This is a binomial number here, so we can't use the AC method. We can, however, use one of those 4 difference of 2 squares, sum of 2 squares, difference of 2 cubes, sum of 2 cubes. This is a difference of 2 squares, namely x is being squared minus 12 is being squared. 12 squared is 144. If we know that, then we can immediately factor this into the first minus the second times the first plus the second. That's how difference of 2 squares formula works. And that's actually factored. X minus 12, x plus 12, those are both linear terms, so we can move on to the next problem. X to the 4th minus 16. This is actually, again, a difference of 2 squares. X squared squared and 4 squared. So 4 squared, x squared and 4 squared. X squared squared and 4 squared. We take the first minus the second times the first plus the second. Now, these are not linear terms. We have x squared in both of them. So we need to continue and ask, can I factor these down further? Well, here we have two separate cases. We have a difference of two squares, namely x squared and 2 squared. And we have a sum of two squares. A sum of two squares can be factored, but not without using complex numbers. Because of that, we actually skip that. We don't worry about that kind of a solution. There are cases where you are considering complex numbers, but we're not doing that here. So x squared plus 4, we call this prime, meaning it cannot factor any further. X squared minus 4, however, can be rewritten as x squared times 2 squared, and that can be factored into x minus 2, x plus 2, and of course we still have the other factor of x squared plus 4. X minus 2 and x plus 2, those are linear factors, and x squared plus 4 is a prime quadratic factor, so we can stop there. That is completely factored into these basic real number factors. Okay, 50x squared minus 72. There's a GCF here, namely 2. We can take 2 out of both of them, and that gives us 25x squared minus 36. And here, I can rewrite this as 5x squared minus 6 squared. And this is now a difference of two squares again. So that 2 still stays on the outside. We have the first minus the second, and the first plus the second. 5x minus 6, 5x plus 6. These are linear factors, so we know that is completely factored. Okay, the next one we can take out a 2x. We have x squared minus 8x minus 9. And this is a linear factor, so that cannot factor any further. That's good to go. This, however, is a trinomial, so we can look into that and say, can we use the AC method? And we can. AC method asks for A, B, and C. A here is 1, so we can use the shortcut method that I showed you previously. And we can ask A times C, 1 times -9 is -9. And B goes on the bottom. What two numbers multiply to give the top and add to give the bottom? Multiply to give the top, add to give the bottom. We have -9, +1. -9 times 1 is -9. -9 plus 1 is -8. And we can immediately factor this, the 2x is still out in front, into x minus 9, because this is a -9 here, and then x plus 1. If that's all confusing, let me just write this using different color here. I just put the -9 right there and the +1 right there. That's all I've done for the shortcut method, and that only works when a equals a +1. Now in the next problem here, we have a equal to -1. And the way we solve this is we actually take a negative out of it. We always want to have the negative not being the first term. It just looks nicer and it's easier to work with. But there is no other greatest common factor here. So I'm going to rewrite this as -1 times 8x squared minus 15x plus 2. Now I have to use the AC method. And a is not equal to 1 here, so I cannot use the shortcut method. So I have to use the very long, the long process here. I'm going to move this over to a little bit more room here. 8x squared minus 5, oops, I forgot. Whenever you take out a -1, make sure you take it out of every single term. This divided by -1 makes it positive. This divided by -1 makes it positive as well. This divided by -1 makes it negative. Make sure of the signs. I made that mistake. Don't make that mistake when you're doing it yourself. We have 8x squared plus 15x minus 2. plus 15x minus 2. And now we can use the AC method. A times C is negative 16, and B here is positive 15. Two numbers that multiply to give the top and add to give the bottom. It's going to be positive 16 and negative 1. Okay, now for the full AC method, you bring down the first term, then you write plus 16 in the middle variable, x, minus 1, middle variable again, x, and bring down the last term. What I've done here is I've just brought down 8x squared, and I've split plus 15x into plus 16x minus 1x, which equals plus 15x. But I've split them up in a way that they're special numbers, which they will do a special property, which I'll show you here in just a second. Now we will take out the greatest common factor out of the first two, out of the second two. Let me use some different colors here to make it a little bit clearer. So what can I take out of it? 8x squared and a 16x. I can take out a 2x. That leaves me with, let's see, 4x plus 8. Okay. What can I take out of these two terms? Because this right here is a negative, I'm going to take out a negative. And the only thing I can take out is a 1, so I'm going to take out a negative 1. That leaves me with x plus 2. Distribute the negative 1 back in, and you'll see you get negative 1x minus 2. So we have done it correctly. Okay, now, I didn't take out the greatest common factor here. This actually can be taken out 4 further. I should have taken out an 8x in the blue. That was the greatest common factor, not the 2. Let me redo that. If I take an 8x out of 8x squared, I just get x. If I take out an 8x out of 16x, I get a 2. And now you see what I was going for. The black here is the same in both of those. So I can write that down. And then I can write down 8x minus 1. So this is completely factored. This is how the AC method works. If you do it correctly, if you do this x diagram here correctly, then you always get the same process here in the black, and you can take that out. It's called factoring by grouping. And yeah, so that's completely factored. These are both linear terms, x plus 2 and 8x minus 1. Those are both x to the power of 1, so they're linear, which means this is completely factored. So we have plus 2 and what was the other one? 8x minus 1. Okay, so that's factoring. Important process for solving solving quadratic equations. Factoring is going to be a technique we're going to use. However, there are some nice techniques that we can use if the problem allows for it. And the first couple are that kind of nice technique. In this case, x is contained within this x, this quantity being squared. If the only x is within that quantity and everything on the outside is just a number, this is actually easier to solve. All we have to do is add 9 to both sides. We get x minus 4 squared equals 9, and then all we have to do is square root. Because x is not on the outside, it will not be underneath a square root. If it is underneath a square root, we end up getting a lot tougher problems to solve. And they're no longer quadratic in nature. The important thing to note here is that if you take a square root or a fourth root or a sixth root or an eighth root or any even powered root, you have to always add a plus or minus. this accounts for the fact that you have two answers here. Namely that if I said what squared equals 4, 2 and negative 2 both squared equals 4. So we have two answers here, and that's what that plus or minus accounts for. So I can write that a little bit clearer here by saying x minus 4, the square root and the square cancel. That's why we're doing that, equals plus or minus the square root of 9. Of course, the square root of 9 is 3. We have x minus 4 equals plus or minus 3. And this splits off into two equations. X minus 4 equals positive 3, and x minus 4 equals negative 3. To solve this, we do the same in both. We add 4, and we get x equals 7, x equals 1. All of these problems, a quadratic equation should always have two solutions. Sometimes they're the same number. Sometimes they are two complex conjugates. In this case, they're two different real numbers. And all of these should probably have two real numbers that I don't think they're going to be the same. So this was a faster technique because x is contained within this squared term. The same thing is true for the second problem. The only place x's fault is found within this quantity with a square, which means all we have to do is add the number on the outside to the other side to get the squared quantity by itself, equals 48, and then take a square root. When we take a square root, we add a plus or minus, and that gives us x minus 10 equals plus or minus the square root of 48. Okay, square root of 48 doesn't have a perfect square. We have to reduce it. And that can be done a number of ways. You can say 48 times 2 times 24, 2 times 12, 2 times 6, and 2 times 3. We're looking for pairs because it's a square root, a power of 2 on it. So that means there's one 2 on the outside and a second 2 on the outside, and there is a 3 on the inside. So we have x minus 10 equals plus or minus 2 times 2 times root 3. 2 times 2 is 4. And now we technically have two equations here. I'm not going to split it up, and the reason why is because 10, when we add 10 to the other side to get x by itself, 10 is not a like term with 4 root 3, which means we can't simplify that out at all. It has to be separate. And we can write that very conveniently by just saying 10 plus or minus 4 root 3. And that is actually two answers there. They are two different real answers. 4 root 3, you can type in your calculator. Let's see, 4 square root of 3 is 6.93 about. So we have like 17 and like 3. That's approximately the values of that. Okay, that's the special method. If you can do that, do it. It's going to save you a lot more time than factoring and solving. When we have trinomials like this next problem, we need to resort to factoring if possible. There is another special method called completion of the square, but I think it's actually harder to do than either factoring or using the quadratic formula. So I'm just going to skip that. But we can always try and factor first. Factoring is going to be faster than using the quadratic formula. But the quadratic formula will always give you an answer as long as you do it correctly. It'll always give you an answer, but it takes a little bit more work. Okay, here we have a equal to 1, so we can use the AC method. AC method, a times c, right? We have a, b, and c. A times c is 45, or I'll write a positive 45 there, and b is positive 14. What two numbers multiply to give 45 and add to give 14? A little bit of thinking, it should give you +9 and +5, I believe. Yep. That multiplies to give 45 and adds to give 14. And we have a equal to 1 here, so we can use the shortcut method, meaning we can immediately factor this to x plus 9, x plus 5. That's because that's plus 9, that's plus 5. Now, this is equal to 0. The only way two things multiplying each other can equal 0 is if one or the other, or both of them, equals 0 individually. So that means we can solve this by splitting this up into two separate equations. X plus 9 equals 0, and x plus 5 equals 0. Solving this for x, we get x equal to -9. Solving this one for x, we get x equal to -5. And so we have two answers, -9 and -5, that give us 0. You can, of course, test these by plugging them into here. Just use a calculator to test them, and you'll see that you get 0 equal to 0 for both of them. And so you get true statements, so you know it's correct. Now, this next problem, this is kind of the general problem that you're going to see. What you're going to want to do always is make the quadratic equal to 0. I'm going to subtract 30 to the other side. Now, this is different from what I did before, where the x was contained within, this is just -40. This is different from what I did before, where in both of these cases, right, the x is contained within this squared term. In this case, I moved the number over to the other side because I wanted to follow this general process of taking the square root and having two answers. Well, if you cannot do that method, then you have to go the other way. You have to make it equal to 0 first. That's what this one, the one I did previously, this one was already equal to 0. Now this one is equal to 0. The next one, the last one, these are all equal to 0, so we're good to go there. It's always the first step, is make it equal to 0. Now we can use the AC method if it can factor. A again here is 1. A times C, let me actually do it off to the side here. A times C is -40. B is +6. Two numbers that multiply to give -40 and add to give +6. That's going to be +10 and -4. All right, yep. So we get A is 1 here again, so we can use the shortcut. X plus 10, x minus 4 equals 0. And again, we have two equations we need to solve. X plus 10 equals 0, and x minus 4 equals 0. Solve those for x. We get x equal to -10, and x equal to +4. You can test, but you'll see that's correct. Now, this next one here is actually, we could actually solve this like we did the first two. I'll show you how. You can, of course, factor it. This is actually would satisfy a difference of two squares. The first thing I want to do, however, is because this is equal to 0, I'm going to divide everything by 4. As long as you divide everything by 4, every single term with an equation, then you can do that. The reason why is because everything has the greatest common factor of 4. We get x squared minus 25 equals 0. Now, what I could do is I could move the -25 to the other side by adding it. And then I have x squared equals +25. And to get x by itself, all I have to do is take a square root. To take a square root, you have to add a plus or minus. And you see we have x equals square root of 25 is 5, plus or minus 5. And I have my answer immediately. If you're unsure of like when to do that, I mean, that's really only ever this case when x squared is the only x term that's involved. You can also see that at this point you have a difference of two squares, right? we have x plus 5 and x minus 5. And you can, of course, solve each individually. Minus 5 there, plus 5 there. We get x equal to negative 5, x equal to positive 5, and that gives you the same answers as that. They're both the same. There's both the same answers, different ways of doing it. It's kind of whichever way that you see it first, go for that. Some ways are easier. Definitely the this first way that I showed you is going to be faster. But if you don't think of it, you don't think of it. So yeah, just use whatever makes the most sense to you. All right, this next one, I can say I can take a 6 out of everything. So I'm going to divide everything by 6. And I get x squared minus 8x minus 9 equals 0. And use the AC method here. A times c is negative 9, b is negative 8. I get negative 9 and positive 1, I believe. They multiply to give negative 9, add to give negative 8. Very good. And since a is a positive 1 there, we can immediately factor it to x minus 9, x plus 1 equals 0. And I get x minus 9 equals 0, x plus 1 equals 0. Solve it for x. And those are my solutions. Again, that was already solved for 0, so we didn't have to move anything around. This next problem, we need to solve it for 0. So I'm going to subtract 12 to the other side first. That gives me 4x squared plus 2x minus 12 equals 0. I can divide everything by 2. That gives me 2x squared plus x minus 6 equals 0. Now I can use the AC method. A is 2, c is negative 6, so a times c is negative 12. B is a positive 1. And the two numbers is going to be the positive 4, negative 3. Yeah, I think that works out. Okay, so this A here is not just 1. So we have to use the full AC method. That's fine. We bring down the first term, 2x squared. Then we write plus 4. And then minus 3. Bring in the last term and get negative 6. So we just split this middle term up into two special numbers. Now again, we ask what's the greatest common factor from those two? What's the GCF from those two? I'm going to write that over here just to make sure I have enough room. So for the blue, I can take a 2x out. That leaves me with x plus 2. From the green, I can take out a negative 3. That leaves me with x plus 2 equals 0. And now you see the x plus 2 are in common. And we have 2x minus 3. Now we have this thing factored to linear terms, so we can solve each linear term to figure out what are the values. X plus 2 equals 0. 2x minus 3 equals 0. Subtract 2. X equals negative 2. Add 3 here. Then divide by 2. We have x equal to 3/2 and x equal to negative 2. All right. 3 more. This problem has no greatest common factor. And it's already solved for 0, so we can use the AC method on it. Doing the AC method gives us a times c. 9 times negative 4 is negative 36. And b is positive 7. Now, what two numbers multiply to give negative 36 and add to give positive 7? 12 times 3. If you're unsure, what you could do is take negative 36, find multiples. We have 1 times negative 36, 2 times negative 18, 3 times negative 12, 4 times negative 9, 5 doesn't go in there, 6 times negative 6. Now you see we're going to go backwards. The next one is 9 times negative 4, and so on. I guess I can write them all out. It's not too much harder. 12 times negative 3, 18 times negative 2, and 36 times negative 1. And all we're going to do is we're going to add up going across. So as we go this way, we add negative 35, negative 16, negative 9, negative 5, 0, 5, 9, 16, and positive 35. And you see in there, none of them add up to positive 7. What that means is that this cannot be solved using the AC method. There might be a way, but it's probably going to be way more tedious than just using the quadratic formula. So that's what we're going to do. We're going to use the quadratic formula to solve this. So quadratic formula works like this. You have to know what A, B, and C are. And we solve it using this formula. It's going to be negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. So just plug in the relevant parts in there and simplify, and you're good to go. There are 2 answers here because we have a plus or minus right there. Okay, so we have x equals negative b. B is 7 here, so negative 7 plus or minus b squared is going to be 7 squared is 49 minus 4 times a times c. A is 9 and c is negative 4. We have 4 times 9 times negative 4. That's underneath the square root there. 4 times 9 times negative 4. That's actually going to be a negative 144, which cancels with the negative that's already in there. Right? There's a negative right here. That's going to end up canceling with the negative. And this is all over 2 times A. A is 9, so 2 times 9 is 18. Now all I'm going to do is I'm going to simplify this as best I can. See what we get. Negative 7 plus or minus 144 plus 1 plus 49 is 193 over 18. And can we reduce 193? I do not believe it is. It is actually prime. If you're ever unsure, you can actually just Google is 193 prime or something like that, and it'll, like, you can read through some of the solutions or the results that you get, and you can see if it's prime or not. And 193 is prime, which means there's no way we can simplify that. So we can actually just leave the answer as this. It's not going to be, we could find a decimal representation of it, but it's going to be kind of long and annoying to work with. So this is actually probably going to be easier to work with. There's nothing else we can do to simplify this. We can't reduce anything by a common factor. That's pretty much the best we're going to be able to do. So that's where we're going to stop. Okay, the next problem, we can divide everything by 3. That gives us x squared plus 3x minus 2 equals 0. And we can ask, is there an AC method here? A times c is negative 2, b is positive 3. Two numbers that multiply to give negative 2 and add to give positive 3. Numbers that multiply to give negative 2, that would be, I mean, you could test this really quick. 1 times negative 2 and negative 1 times 2. Those are the only two possibilities, right? But that gives us negative 1 and positive 1, which means the AC method doesn't work here. So we have to use the quadratic formula again. And so we have A is 1, B is positive 3, and C is negative 2. Using this formula that I wrote here previously, we have x equal to negative b. B is 3, so we have negative 3. The square root of b squared, 3 squared is 9, minus 4 times a times c. A is 1, so 4 times a is 4, times c is negative 2. So we have negative 4 times 1 times negative 2 is going to be positive 8. Rewrite this radical. All over 2 times a. A is 1, so we have 2 times 1 is 2. Simplifying this, we get 17. 17 is prime for sure, and there's no common factor there. So this is pretty much the best we're going to get. We can't simplify there. You always have to see if you can take anything out of all the terms and if you can reduce the radical. For instance, if I had something like negative 4 plus or minus 3 root, sorry, not 3, let's do 8 root, I guess 12, all over 2. The first thing we can do is we can simplify root 12. 12 is 4 times 3, and 4 is 2 times 2. There's a pair of 2's, 3 stays on the inside. That means we can take a 2 on the outside. So we get negative 4 plus or minus 8 times the 2 from the outside, right? That's the 2 there. And the 3 stays on the inside. This is all over 2. Simplifying the 8 times 2, it gives us 16, root 3 over 2. And now you see that we can break this up into negative 4 over 2 plus or minus 16 root 3 over 2. And these can be reduced. Negative 4 over 2 can be reduced to negative 2. 16 over 2 can be reduced to 8. And we have a simpler expression here. So this would be the correct answer, not just this, right? This can be simplified down to this. So you always want to simplify the radical and simplify if anything can be reduced between the numerator and the denominator. Okay, moving back. The last problem here, this is not a trinomial. It's not a binomial. We can ask if there's a greatest common factor. There isn't in this case. This is it's really not called like quadnomial. It's really called just a polynomial. But we can always try factoring by grouping. If it works, then we can factor it further. If it doesn't, then we really can't do anything else to it. What can we take out of x squared and negative 5x squared? We can take out an x squared. That leaves us with x minus 5. Now, out of negative 4x and positive 20, since we have a negative here, I'm going to take out a negative. And we can take out a negative 4 from both. That leaves us with x minus 5. And you see the black is the same here. So we get x squared minus 4, x minus 5, and x squared minus 4. This is a difference of two squares. So we can factor this down to x minus 2, x plus 2, and the x minus 5 is still there. Now we have 3 linear terms, and each one of these can equal 0 to give us a different solution. So x minus 2 equals 0, x plus 2 equals 0, and x minus 5 equals 0. Solving this, we get x equal to 2, x equal to -2, and x equal to +5. And here we have 3 answers, right? All 3 of these are solutions to this original equation. And that's because we have a cube there. In fact, that power, the highest power, the degree of the polynomial, will tell you how many solutions you should expect. There could be a variety, right? You could have complex, you could have repeating solutions, right? We could have had +2 twice. That's still 2, that counts as 2 individual solutions. And you can have also 3 distinct solutions, things like that. So to recap, there's a couple methods here that we used. One of the first ones I showed you was this where we take the square root of both sides. Whenever you do that, make sure you add this. Let me do it in orange here. This plus or minus. That's very, very important. Make sure you add the plus or minus. That's what's going to give you 2 solutions. That's the first technique, and that only happens when the x is contained within a squared term. It's not on the outside. The next one here is to use the AC method. If a equals 1, we can immediately use this shortcut method here. If a does not equal 1, let's see if I can find one here. Yep. In this case, a did not equal 1. So we had to use the full AC method, which involves factoring by grouping. That's going to give us these 2 solutions here that we then solve. That's the AC method. And then if possible, if you can't use the AC method, then your next solution really is the quadratic formula. That will always give you a solution. It will actually find you every single solution possible, even complex solutions. Of course, if we do not have a trinomial and we have this quadrinomial or whatever, if this is given to you, you can try factoring by grouping like I did here. If that doesn't work, then there's really nothing you can do. You can just kind of stop there and say you cannot solve. But typically, if you're gonna be given a problem like that, then factoring by grouping will work. So really quickly, I want to talk about the discriminant. It's a portion of the quadratic formula, and it actually tells us what kind of solutions to expect. The first thing you need to do to find the discriminant of any quadratic is to get it in the form of ax squared plus bx plus c equals 0, just like you would for the quadratic formula. Now, if it's like in this first one, which this one we already found was, I believe, yeah, it was 10 plus or minus 4 root 3. Those were the answers we found. Now, to do this right, we have to get it in the ax squared plus bx plus c form. So I'm going to have to expand the x minus 10 into the full quadratic. So doing the foiling it out gives us x squared, and then minus 10 is minus 20x, and then minus or plus 100 minus 48 equals 0. That's just doing the FOIL method faster. And then combining like terms gives us minus 20x. This should be plus 52 equals 0. Now we have this into ax squared plus bx plus c. A is just 1, b is negative 20, and c is 52. The discriminant says take, if you don't remember the quadratic formula, is negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is, what is this portion here? B squared minus 4ac. So b squared minus 4 times a, which is 1, times c, which is 52. Now, plugging it in a calculator gives us minus 4 times 1 times 52, 192. Now, 192 is a positive number. If b squared minus 4ac is greater than 0, this means we have 2 real solutions. Real being the number set, the reals. And that is what we got. We have 192, so we get 2 real solutions. That's what we got here. 10 plus 4 root 3 is a real number. It's on the real number line. And 10 minus 4 root 3 is also on the real number line. So that kind of gave us a preview of what to expect. Okay, now for this next one, I need to add the 10x to the other side first to get x squared plus 10x plus 25, and this equals 0. Now this is in ax squared plus bx plus c form. A is 1, b is 10, and c is 25. B squared minus 4 times a times c. Plugging that in gives us 100 minus 100. Oops, I shouldn't write equals 0 there. And this equals 0. Now, if b squared minus 4ac equals 0, we have one real solution. And it's repeated twice. You can see that by looking at this quadratic here and factoring it. Using the AC method, a times c is 25, b is 10. Two numbers that multiply to give 25, add to give 10, that's 5 and 5. And since a is 1, we can use a shortcut method, giving us x plus 5 equals 0. And that means the only solution we get from this is x equal to negative 5. We have one real solution. It's just repeated twice, what you expect. Now the final answer, or the final type of thing, is when b squared minus 4ac is less than 0. Now the question here is what do you expect it to be? Well, there was 2 when it was greater than 0, and there was 1 when it was equal to 0. So less than 0, it's actually going to be 0 real solutions. There has to be 2 solutions though, right? This is 2 times 1 real solution. The first one is 2 real solutions. That means these solutions are complex. So really that's what we're saying here, is that it's 2 complex solutions. And we can do that here. A here is 1, b equals 0, and c equals 1. Doing the b squared, 0 squared minus 4 times a times c gives us negative 4. If you're to use the square root method, x squared plus 1 equals 0, subtract 1 to the other side, take a square root, we get x equal to plus or minus the square root of negative 1, which is I. And that's 2 complex solutions. That's the way you could solve it if you wanted to. We're not too worried about that case because we can't graph that. We don't have any good visuals for that for this level of mathematics.